what are the things we have to discuss today? Types of intermolecular forces. Types of intermolecular forces. Types of intermolecular forces. So what type of intermolecular forces that are likely to exist? Why we need to discuss about the types of intermolecular forces? Because the type in the strength of the intermolecular forces will decide the behavior of the behavior of the gases depends upon the strength of the intermolecular forces. Now coming to the first type, ion dipole. This type of the intermolecular force, this type of the forces will exist between an ionic compound and a polar covalent compound. Ion dipole type of forces will exist between an ionic compound and a polar covalent compound. Next, dipole interactive forces. Interactive forces. This type of the force of attractions will exist among the polar covalent compounds. Now dipole and induced dipole attractions. Dipole and induced dipole. The first one is ion dipole, which is likely to exist between an ionic compound and a polar covalent compound, and dipole type of interactions are present among the polar covalent molecules. Dipole and induced dipole type of attractions exist among a polar covalent compound and non-polar covalent compound. In polar covalent compound, permanent dipole will be present, which will introduce a temporary dipole among the non-polar compound. Next, among the non-polar covalent compound, the type of forces are called London dispersion forces, or we can popularly call as Van der Waals force of attraction. In this type of the force of attractions exist among the non-polar covalent molecules. What happens? How this type of the force of attractions are generated? So normally what will happen? The distribution of the electrons around the nucleus will be symmetrical. For a moment, the symmetrical distribution of the electrons around the nucleus will get dispersed, leading to the formation of a temporary dipole. So when we consider helium or any other non-polar covalent compound, first temporary dipole will be induced, because momentarily when the symmetrical distribution of the electrons around the nucleus gets disturbed, it leads to the formation of a temporary dipole. This temporary dipole will induce another dipole in the neighboring molecule. So this type of the forces are called induced dipole and induced dipole interactions. And strength of the London dispersion forces will increase with increase in the size of the molecule, or with increase in the molecular weight. Among the hydrocarbons, with increase in the length of the chain, strength of the London dispersion forces will increase, leading to the higher boiling point. Among the alkanes of the same molecular weight, if there is a branching take place, due to the branching, what will happen? The surface area decreases. When the surface area decreases, the strength of the this type of the London dispersion forces will be reduced. This is briefly about the strength of the types of intermolecular forces.